The first four stages of a pattern are shown in the diagram below. If the pattern continues, how many red boxes will there be in stage 10 of the pattern? Write an expression for the number of red boxes in stage n of the pattern. So this one is, it's not an equation because it doesn't have an equal sign. We can show the expression as well. Again, it's kind of just a formula for this. But how many boxes will there be in stage 10 of the pattern? So just to start out, we can count how many red, oh crap. All right, so the first one, you can count them. I counted 6. The next one, 10, then 14, and then 18. Okay, so the pattern that I see here between each of the stages, this is stage 1, stage 2, stage 3, is that each of them is adding 4. So, for example, you do 6 plus 4 to get your 10, 10 plus 4 to get your 14, 14 plus 4 to get 18. Now, I don't want to do this 10 times either, right? So what I can do is just say, well, there's actually several different ways to do this. Now, I'm not going to draw this, not because my drawing sucks, because I'm actually too lazy to draw it. But stage 5, so let's do that. Okay, so we got stage 4 has 18 red squares there. We're going to add 4 to it because we know we're just adding 4 each time. And that will tell me how many boxes that would be red would be in stage 5. 18 plus 4, boom, 22. All right, now here is something that happens from time to time. We want stage 10, and we say, look, here, we got stage 5, and now we can scale this, right? So if we scaled it, that means we're just going to multiply this by 2 to get stage 10, and then we'd multiply this by 2. I'm not going to do the math, but it'd be 44. There's a reason why this doesn't work. We just haven't done enough work to really explain why it doesn't work. But I'll say this, is if there were, and this is where it kind of gets a little important there, if there were a stage 0, in order for this to scale like we did, you would have to multiply, you would have to have 0. You'd have to have a 0 here as well. But that doesn't fit the pattern, because then you would have to add 6 to get to this 6, and then you'd have to add 6 every time. But we can see we're adding 4 every time. Okay, now, again, I'm not fully explaining why you need 0 squares there, but let's take this, what we have. Okay, so again, let's take that same idea of scaling. So again, we know that 0 there doesn't work. We could scale with the 2 as well, right? We could come up here and be like, okay, I'm going to scale the 2. If that were the case, then I would multiply the 2 by the 5 to get stage 10. And then I'd multiply the 10 by 5 to get 50. But again, the answer is not 50. But you can see at least we got 2 different answers. If we scaled this value, then we had 44. When we scaled these values, we got 50. Very different answers. Yeah. So we can't do that. We cannot scale those unless, the only reason we could scale those is if we had no red boxes in stage 0. One thing that we will want to notice on this, that we're adding 4 every time, right? Yeah. So I guess I'm kind of jumping to part B here because maybe it'd be helpful. But if we see that we're adding 4 every time, add 4, add 4, add 4, add 4, that's repeated addition. So what I could do is just, instead of using repeated addition, just change that to multiplication, right? So what we could do is we could say, you know what, I know that I'm just going to multiply by 4, and I'm doing it down here at the bottom because I don't really care what stage I'm in, right? All right, so if I do this for stage 10, so I'm going to add 4 every time. I'm going to do this how many times? Stage 10, right? Stage 10. Now that would be 40. Now there's not 40 in stage 10, but I'm just kind of trying to get us there, right? Okay, so these 40, what would these 40 represent? Well, think about it like this. If you were to do stage 1, right? So that would be, let's go to stage 1 there. That'd be like you got 4, and well, you'd have 4 times the 1 there, and that's 4, right? Now there's six red boxes, so that means that 4 you'd have to add 2 in order to get the 6. Now I added these 2 arbitrarily just because I know 4 plus 2 is 6, and I know that there's 6 red boxes. The question is, where are those 2 red boxes? Well, let's see. Before we answer that, let's go to the next part. So let's go to the stage 2. So again, stage 2 would be, since it's repeated addition, we know we're going to take 4 and multiply it by 2. Now that's going to be 8. That's going to be 8. But again, I see that there's actually 10 total red boxes. So I would have to add 2 to that to get 10. Okay, so we're seeing another consistent pattern here, aren't we?
Yeah.
After the multiplication, we add 2, don't we? So let's see if it works for all of them. So 4 times 3, that'd be 12. There's, in stage 3, there's 14 red boxes. So again, we see the add 2 thing to get 14 red boxes. All right, that's looking pretty good. What about 4? Stage 4, well, 4 times 4 is 16. We're still 2 away from 18, so we'd need to add 2 boxes, 2 more red boxes to get 18 red boxes. Now let's just double check with the one we found. 4 times 5 is, that'd be 20 of those boxes. We're still 2 away from 22, so it's 22. Okay, so in this string of finding values, which is really going to help us to figure out the expression as well, we're adding 4 every time, which is where this multiply by 4 thing comes in. But we notice in each of these cases that we're adding 2 as well. So you do the multiplication, which we did right here, and then after the multiplication, you simply add 2. Boom, you get 42 red boxes in stage 10. 42 red boxes. Now that's nice, and maybe we wouldn't have noticed that, but here's the thing, is where does the plus 2s that we got in here, all these plus 2s, even this one, in the boxes, in the diagram, in the picture, where are the 2 boxes? I would also say that these are the 2 middle ones right here, because look, you got, remember this was 1 times 4, right? 4, 1, 2, 3, 4. Okay, 4 times 2, 2, 4, 6, 8, then the 2 in the middle. This one, 4 times 3, 12, 3, 6, 8, oh, suck. Let me try that again. I did just, oh man, here we go. 3, 6, 9, 12, all right. Sal does know his multiplication tables sometimes. Okay, but there's the 12, there's the 2 in the middle, right? 12 plus the 2 in the middle. How about this one? 4, 8, I'm taking my time, 12, 16. Okay, so there's the 16, 2 in the middle, boom. So when we're adding these 2, there was these 2 in the middle that were just always there, right? And then I would say these, I don't know, I'm starting to think of spider legs, but whatever. You know, they're just these legs that are just growing out from the middle right here. And that, just to go back, that means that stage 0, this is significant. It's just not significant now, but stage 0 has 2 boxes. It would have been the 2 middle ones right there. So in the next part, it says write an expression for the number of boxes in stage n of the pattern. Okay, well, stage n, again, we can see that all we're doing is taking 4 and multiplying it by the stage there. So this one just happens to be stage n. We don't know what that number is. But after we multiply by 4, that tells us how many red boxes are branching out from the middle, and then the middle has the 2 red boxes. That's it. That's it. So we got that answer. Stage 10 has 42 red boxes, and then the expression would be something like this. So now that we have the expression, and it didn't ask for this, but if it said, you know what, how many red boxes would be in stage 100? Because I don't want to draw that crap. But it'd do 4 times 100, 400 plus 2, 402, boom. Could you do 70? Sure you could. You could do 70, you could do 1,000,000, you could do, I don't know, stage -10, I don't know, whatever. But this expression now becomes a formula for this diagram. There we go.